Hello, everybody.
Hey guys, let us know if you can hear us. Looks like they can. We're gonna assume that.
Yeah, why not? Yeah.
I'm glad you asked the question.
Yeah.
So
They're really rhetorical questions
that's fair.
at this point.
So we're here today with these two community guys. I'm doing the intro. Surprise!
Whoa.
This is Brian, Spark Thomas, SparkZack, or AKA Team Dakota's resident dungeon master.
That's true.
I will now always
In
be
more
able to
ways
say
than
that.
one.
Yeah.
In more ways than one, indeed.
That's a little reference to our D&D group.
Yeah, so I was quite at home making this dungeon. But today, we're going to walk you guys through how our dungeon generator works in the upcoming dungeon pack. So hopefully we'll just give you a little overview of how this brain functions, what you can do with it, and near the end, we'll show you some ways you can customize or improve it if you'd like to. So,
Sweet.
I think this will be the first time everyone's seen this in the Create.
We showed it a tiny bit last Thursday, but
Okay.
this is we didn't go through the brain. The brain is, 9? It's 9 pages of code.
9 pages of code.
It's got a lot going on. So Zach's going to walk you through exactly how he put it all together, how he made it. So you understand the fundamentals of it, and
Yeah.
then how you can change it to do whatever you want for yourself.
Pretty much. And if you guys have any questions at any point, feel free to ask. I'm going to be on cruise control, trying to explain everything.
We'll be the
Yeah.
two people asking the dumb questions.
Yeah, just want to first thing point out you have really nice hair.
Thank
Yeah,
you.
according to chat.
Yeah.
It's always true. Always true. Observant. Okay, so this is what you plop in. What you'll see is, I believe, 5 logic cubes and 6 what I'm referring to as dungeon tiles. So as you can see, these dungeon tiles are templated, and this logic cube is not. So what this actually is, just real quick, is each one of these is a different kind of builder block for our dungeon, right? We have our corner here, we have our wall here, we have a hallway here. This is where our hallway, our end cap / door, like a doorway, right? Here, and these two are entrance and exit. And you'll see the entrance and exit, or I should say specifically the exit. This door is attached to this prop. Everything else is glued. So these are all glued, and the door has some special code on it that we'll go over later. It is attached to that prop.
Cool.
And this guy, we'll get to as to why he has so many Logic Cube buddies with him, but there's a reason he has a horde of a couple friends. So, if we just go in here and press test, the first thing we're going to see is this lovely, lovely screen. I probably spent the most time on.
The
dungeon.
black screen?
Yeah.
The black screen, it was pretty hard.
Okay.
So as you can see here, we've entered our dungeon. We have some goblins running around. We got a sword pickup in our first room, which is pretty lucky. And
And
we
a
also got a
coin.
coin. Yeah, we got a little bit of everything.
Mhm.
So right now, those are the 3 objects that spawn into this dungeon, is the sword, the coin, and the goblins. We'll go over how to change that, but that's the basic makeup.
I thought, so you only have swords? Those are the only weapons? I thought I saw a dagger somewhere, but I guess I was wrong.
No, I don't believe you did. So...
Yep, that was just me being wrong.
So we can kind of go around here. All of the rooms we're walking around right now have been randomly generated. They're not going to hit each other, and we don't quite know where the exit is going to be spawned. And it's going to be a random makeup every time we generate this guy.
And it's 8 rooms?
It's right now set to a default of 8 rooms. So every
Okay.
time you generate a dungeon, it will generate 8 empty rooms, and then spawn entrance and exit in random locations.
Are the rooms all the same size?
The rooms are not all the same size. So, this is a cool thing. Let me first show you how the exit works. So now this is our exit. Our entrance has stairs. This guy has stairs going down. We hit this button, and we'll go onto our next dungeon.
The next floor.
Yeah, the next dungeon floor, so to speak. So if we pause here and go into our screenshot mode, we can zoom out, and you see we have this randomly generated dungeon. It looks like we have at least one of every room. We have our big 5-room guy. We got a couple small 3 room.
Like so, when you're saying 5 and 3,
Yeah,
then
so
that's...
it's how many tiles, right? So you can see
Got
that
it.
this is 3 tiles long by 3 tiles tall. This is 4 tiles long by 4 tiles tall. And then this is the same thing, 5 by 5, right? So we got our 5 by 5. This looks to be a 4 by 4, and this looks to be a 3 by 3. You might also notice that the hallways are different lengths randomly as well.
That's very cool.
And you can see here in this guy, it looks like we got our exit here and our entrance here. So that's how the dungeon works. And I've tested up to room 12. If someone gets to a triple-digit room and it breaks, let me know. I do not know if you can get to room 100 without everything going haywire, but I assume it's fine.
And currently, right now, it's always square, right? Not rectangular?
Right, exactly. But we will go over how, if you'd like to, you could change that. But by default, that is what it is.
Cool.
So let's go in and see how exactly we went about doing all this. So we'll open up a brain, which is the logic cube closest to the templates. And this is the random dungeon build. So this is our first page of 9 populated pages with code. And while this is called the init page, this actually we come back to this page every time we'd like to make another floor or another dungeon, whichever you like, whatever you'd like to use. As soon as you hit the exit, we come back to this page.
And init just stands for initialization.
Right.
It's short for
Correct.
initialization.
Right.
Just for those of you who are like, what is init?
So when this page is entered, we say floor is incremented by 1 because computers count from 0. So that means we start at 0, we end up with 1. And that'll be your first dungeon room. We say we'll skip a lot of this and we'll come back to it because a lot of it's resetting. But what you need to know is happening right now is we're making sure we're not destroying equipment, we're dealing with some containers, we're setting some vectors back to 0, that's all whatever. We'll deal with the reset stuff later. The important part is we're taking these dungeon halls and I'm saying it's one of these templates. And I say my dungeon exit is the dungeon exit template. I'm saying my dungeon entrance is the dungeon entrance template. So I'm setting all these templates as objects on the first page, right?
And so this is where you could, for instance, you could make your own dungeon set.
Exactly.
Yep. Add tiles to it, basically.
So pretty much, if we'd like to, you could go into one of these templates, change it around, re-glue it, and on the first page, right, lines 25 through, I believe it's 30? Yeah, 25 through 30. Those where that is where you'll be able to change the look of your dungeon. So you go find the corner. You say, well, that's a cool corner, but I think it can make a better one. You go in, mess it around. Maybe it's not even a dungeon anymore. Maybe use the keys of the castle pack. Maybe use the Kodite runes pack. Whatever. And then you can change that here and point it towards that corner piece.
Awesome.
And then we do some more resetting. We don't need to worry about that. We wait for 4 frames and then we go on to the next page. So the first time we're initializing this, the important part is lines 25 through 30, we're setting these templates. Now we're on the next page. So you'll see the first thing we do on the main page is we set room creation equal to true. The first thing this dungeon actually does is create a room. The second thing it does is find out who the player is, saying for each of player equals it, and its position is equal to where I started, aka where the dungeon will start.
So if, for instance, say you have a game where you have the player controls in a bunch of logic cubes, would that set all of those logic cubes plus your player to all be equal to the one position of the start?
I believe it will.
Okay.
Mm-hmm.
Or it will assign the one you put in the world last. It'll do one of those. But I assume you only have one player. If you have more than one player, this thing could get a little iffy. You might have to come in and change this.
Right. Like, just you can actually make it in-world picker and set it as your player.
Right,
or
exactly.
Or do whatever you want.
Exactly. Instead of win for each of, I could say player equals, and then I could grab my player here instead of it on this tile on line 2. So then we grab our player. We set its position equal to the origin, which is where we're starting our dungeon. And then we say deactivate its brain. We don't want you around anymore.
Something good brought up in chat by Mescat is that would deactivate the brain of only the last one assigned to his player.
Yes. Like I said, we're assuming there's only one player at the moment.
Yep.
So then we set a fade time. We do it super quick, fades to black, and we display that we are building the dungeon, and you're gonna have to wait around for a second. We'll get back to these reroll booleans in a second, but we have some reroll booleans. That helps to do with hallway creation. And then this is booleans for passage creation, hallway creation, and room creation, which we'll be stepping through soon. And then right here is where it says room started to equal 8. You could change this number on line 24 to any number you'd like. As long as you don't hit prop limit, it'll create that many rooms. I believe right now it can create roughly 23 to 24 rooms, depending on what the size is. So you can get about 24, 23 rooms if you'd like. Right now it's set to 8 because we kind of assume maybe you have some props in there. Maybe you're putting this into a world you already have populated a little bit, so we're not going to immediately take up all your prop count. But you can set this line on this code tile on line 24 to whatever number you'd like, up to about 24. Or up to, yeah. That's funny. It's the same line as this nice number.
Yeah, that's an easy way to remember.
Yeah, right.
If you have more than 24 rooms, you're going to hit the prop limit, and it won't create all those rooms for you. So,
and then this I would not mess with. You could, in theory, create more exits if you change this room. I wouldn't do it. Don't. This is what will create our exits and entrances, which I call passages. So So an entrance or an exit to the dungeon is called a passage, and that's what this number represents.
So that's saying once you have your 2 passages created, go to the next
go
page.
to this is the last page where we add everything called populate. Okay. So we'll go back up here, and we'll say the first thing that happens on this page, we're going to be stepping through most of it, but room creation equals true. So we know when room creation equals true, down here, we're going to be calling page room create, or create room. So let's go to that page, and I'll step you through how we do the tile generation. So every tile or every object we place down is in a 4x4 square. And so if you'd like to have bigger tiles, that is possible by changing this number here. So left multiplied by 4. This tells, when we see this multiplied by, when we're setting our position, this number that follows it is the assumed size of every tile that you have. So if you wanted to make bigger tiles, which we don't support at the moment, but if you wanted to make custom tiles for this generator, you could set it to 8 or something, and that'll be the default size will increase.
Okay.
It'll be, I believe, this and one other area we'll point out. So the first thing we enter the page is we move. We say, okay, we're starting now. Let's move. Our position equals more or less left. To the 4 to the left is what plus left multiplied by 4 means.
So it's 4 places to the left of that
4
current
meters
logic
to the
cube.
left of the current logic cube.
Okay.
Our tile is equal to nothing. Our ID is equal to 0. This will be important. ID is very important. Our target position is equal to our position, which we just set up here, which is 4 to our left. Target position is where we're going to be spawning in a lot of things. And now this is kind of a complex idea that I'll try to step through slowly. We have 2 numbers here called I and J. They're randomly generated. As you can see, I is randomly generated 3 to 5 as an integer, and J is I minus 1. So if I was 4, J would be 3. If I was 3, J would be 2. And what this does is we're going to do what's commonly referred to in computer science is a for loop. And so this is how we're going to create all of our tiles. And the reason we need 2 numbers is because I creates our first row of tiles, right? If you could imagine, it creates the top row of tiles, and then J will create each row of tiles going down. So you have 1, 2, 3, and then for each one of those you have 2, 3, 2, 3, 2, 3, and that's how you get a 3 by 3.
Okay.
If that doesn't make sense, hopefully stepping through this will help.
So
That makes sense.
So could you think of I as like the width, J as the height?
Yes, absolutely.
And so therefore, if you change the J, that would be how you change the height to be
Absolutely.
different from the width?
So doing both, by changing this number, you can get a lot of different room types. It's very easy to make like a boomerang looking room. It's very easy to make a U-shaped looking room. It's all very easy to do. If you want to change how your rooms are laid out, all you need to do is change this area right here. And that will change the different makeups of the room or the different sizes of the room. All done through 2 what we call for loops. And when you have a for loop, which means for each of, right? That's why they're called for loops, not like the number, but for like the FOR word. When you have 2 for loops in something, the second one is considered a nested for loop.
So what's the reason for calling them I and J? Is that like a standard equation?
It's a standard, it's just a mathematical standard that I unfortunately couldn't tell you. It's usually how, I think I means integer, so you know that it's an integer and not like a half number or something.
Okay.
And J, I believe, is the second next letter in the alphabet.
Yeah.
Okay.
I always thought I was like a iteration.
It might
like,
be iteration.
As you iterate through like a for loop.
Yeah, iteration equals blank. It's either iteration equals blank or integer equals blank, and then J just happens to be the next letter in the alphabet. But it's shorthand used in CS a lot, and it's just a common convention.
It also makes you look smart when you use it.
Okay. Okay, so for each of I, which we know is a random number between 3 to 5. So that ID thing we were talking about, it becomes incredibly important right now. So every time, you have to think about this, is now, this happens every time we create a tile. Every time we create a tile, this is about to happen. So even though we're reading this line of code once, you have to think about this happening at least 3 times. It's most likely going to happen like 4 to 5 times, right? So for every tile we create, your ID is incremented by 1, which means the ID of this object, which is the logic cube. So the first tile I create, it'll be 1. The second tile I create, it'll be 2. The third tile I create, it'll be 3. Tile, this is just, we're creating a dungeon floor. Again, this would be where you would change this object. You could easily point this at a template, and you can completely change the look of this brain. But right now, its default is the dungeon floor. So our tile is create at position, target position. You'll remember our target position is what our position is. And then we say the tile's forward is equal to R forward, so we know it's always faced in the right way. This also means since we're using R forward, you can technically place this logic cube anywhere and rotate it any direction, bar up and down, and it will generate how you want. So if you'd like to have your dungeon rotated a little bit, that should be fine. You can rotate which way the dungeon will be created. The tile's name is equal to I. So this is another important thing. So the tile's name, which is a string on the tile, is equal to the number which we randomly rolled for here. I equals random number 3 to 5. And so what I'm doing at the moment is I know I is a number between 3 or 5. I call it that name. I automatically know that if your name is 3, you're part of a 3 by 3 room. If your name is 4, you're part of a 4 by 4 room. If your name is 5, you're part of a 5 by 5 room. So I know everything I make by the name of what it is, what room it is a part of. Then I have a second number that says the ID is equal to the current ID. And remember, we're setting the ID every time we go through the loop. So the first tile I create, its ID will be 1. Its second will be 2. Its third, it will be 3. So I know when I'm creating these rooms, if your name is 3 and your ID is 9, you must be on the far corner of the room from when I started. And then if your name is 3 and your ID is 5, I know you must be in a certain specific position in that room as well. So by knowing the name and the ID, or the amount of the room and which tile in the creation process you were, I am able to point where you or I'd be able to pinpoint what position you should be in that room. And then we put them in a lot of different, we increment tile to a lot of different containers because we're going to be doing different stuff with them, object sets. So we add them to tiles, we add them to spawn tiles, and we add them to dungeon items. Spawn tiles, we'll go over that later. Now, this is for the first row, or how Brian was saying, the length, right? We've just set the length. Now we need to set the height. So I say sub-target position equals target position. And position plus forward multiplied by 4. That means every time I'm going to move, right? So we're placing down a tile, moving, placing down a tile, moving, placing down a tile, moving, okay? And that's what this logic cube is doing. It's like, boom, okay, tile, this is your ID, this is your name, this is the things you need to be a part of. Okay, you good? Okay, on to the next one. Okay, this is your ID, this is your name, this is the things you're a part of. Okay, on to the next one, right? So we place something down, we move. We place something down, we move. We tell it what it is, and then we move on.
And, all right, stupid question time. Is it 4 because each tile is 4 meters long?
Yes.
Okay.
That is why. So again, this is so I said there were 2 numbers you'd have to change to make the tiles bigger. This is the second number. So the one at the top was left multiplied by 4 and forward multiplied by 4. If you change these to 6, 8, whatever, that will change the assumed size of your tile.
So the actual tiles, they're 4 meters long.
Yes.
Okay, those dungeon tiles. Cool.
Now, this is where it starts to get a little interesting. We're about to go a little bit down the rabbit hole. So you see we have for each of j here, and for each of j is under for each of I.
Oh.
So that means every time we put a tile down on I, we're going to be doing this. If say I was 3, this is going to happen 2 times for every 1 time this happens. And if it was a 5 by 5 room, this would be happening 4 times for every 1 time this happened.
Okay.
So every one time this happens 4 more times. So for each of j, which will be I minus 1, you increase the ID again. You move to the right because now we're going boom, 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 boom.
Yep.
Boom, 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 boom. Right. So let me explain that a little better than just saying boom a lot. So you spawn your first tile, and it says, okay, for each of, let's say 4, okay, so 4 more times we're going to go down. Okay, we're back here. 4 more times we're going to go down. Okay, we're back here. 4 more times we're going to go. Okay, so for every time you're going across the top of this, you have to go the height as well.
Got it. Okay.
So that's what sub-target position is. So we need to know our target position, but that's only for the first 5 that we place, if it's a 5 by 5 room. For the other 20 we're going to place, we need sub-target position. And sub-target position is pretty much the same thing. It's iterating the same way and doing all the same stuff as what we just saw in the first time. We're still setting the name, we're still setting the ID. The ID is still increasing as you assume it would. But now we're using sub-target position because we need a second position, because we need to go back to target position when we're done.
So that's also increasing the ID then. So then when you get to the second row, which is the I, then the ID might be, like if you have 5 rows, the ID might be like 6 for that first one.
Right.
Okay.
Exactly. Exactly. So obviously in a 5 by 5 there'll be 25 different tiles and you'll have ID 1 through 25. But you know its name, so you know if its name is X and its ID is Y, between X and a Y, you know exactly where it is in that room.
This guy makes a good analogy of, like, think of this sort of like a calendar. Every time the month changes, you do another loop through the 30 days in that month. And then the month changes again, you do a loop through the 30 days. So here it's like you start with your width, and then you do a loop through the length. You start with your width, and then you do the next point in your width, and you do loop through the length, and so on.
Yeah, absolutely. Okay. So now we also call page configuration. So at this point in the brain, we've laid down every single tile in our room. This is our first room. We've laid down every single tile in our room. It all has a name that corresponds to what its size is, and it has an ID that corresponds to what order it was created in. We're now going to call a page called configuration. So let's move to configuration. So in configuration, we're going to check the name and the ID of these things, and between the ID and the name, we'll know what it should be. So tiles, if you remember, we're adding all the objects we created to this tiles container. if it name is equal to 3 and it ID is equal to 2, we make sure everything's fine. Pretty much we're going to create a wall. So let me think about which best way to do that. So if your name is equal to 3, meaning we know you're a 3x3 room, and your ID is equal to 2, meaning I know that you're one of the walls that could possibly, you're one of the tiles that is a wall that could also possibly be a doorway.
Okay.
Mm-hmm. You're not on the outside.
And you're not a corner. We know you're not a corner.
And we know you're not a corner.
Because on 3 it would be like 1 or 3.
Right. It would be exactly. So if you're 1 or 3, we know you're a corner. If you're 9 or 7, we know you're a corner. But if your ID is equal to 2, then we know you can possibly be a wall. So we say create wall equals false, and then we have it. So it is now something with the name of 3 and the ID of 2. So we know which one we're going to tell to detect. We say, do you detect anything? Well, if you don't, then we're going to create a wall. If you do, nothing's going to happen. Okay, you didn't detect anything. We're going to set create wall equal to true.
Mm-hmm.
And this means that we're now creating those walls. And creating walls means we're taking the tile, because in the last create room thing, you see we're only creating dungeon floors, right?
Yep, it's just the bottom.
Just the tiles. Here we're changing those tiles into dungeon walls. And so when create wall is true, right? When we know these are right, we say it visible is equal to true. That was a debug thing. Don't worry about it. It forward is equal to forward, meaning we're going to turn the wall in the right direction, right? So we know which direction it should be headed in. Wall equals create dungeon wall at position it. And then we actually destroy the tile that was there and replace it with the wall.
Mm-hmm. So far what we're seeing is you've placed all the tiles down, then you go through and see what can be walls, and you like remove that tile and slot in the wall tile set.
Exactly.
Cool.
And then I say, okay, you're now part of walls, because this is going to be important later. So once I've said you're a tile that can be a wall, okay, let's make you a wall, get rid of the tile that was there. We now have a wall in that position. Now I want you to be added to this wall object set.
So at this point now, when you replace it like that, do you have to retell it what its ID and all of that is, or do you not need that information anymore?
I don't particularly care at this point.
Cool. You just need the ID and name to know what to replace it with. Okay.
Right. And I'll do this, you'll see, for each different ID in a 3x3 room, because I need to, each wall is turned differently. So wall forward is equal to right if your ID is 4. Wall forward is equal to forward if your ID is 2. So for each different direction you need a wall to face, you need to say that ID. So for the 3x3 rooms, you'll see it's only one number. For the bigger rooms, you'll see that number is, or it'll be a range of numbers. So let me go down here. So it is equal to, it ID is equal to 6, or it is ID is equal to 11, or it ID is equal to 16. Then we can create a dungeon wall that's positioned to the right.
Okay.
Because now there are 3 different tiles. This seems to be a 5x5 room. There are 3 different tiles that we need to turn a direction.
Okay.
To make the wall face in. So hopefully I've kept everyone through this.
People are hanging on by a thread right now, like, I think I get it.
As it's like slowly falling.
Basically the idea here is you see what the name of you see the ID and you see the name and you rotate it. And there's a lot of different for loops, there are a lot of different for loops, but basically the whole idea here is I see what the name is, what your name is, and what your ID is. And between those two different things, I say you should be rotated like this, you should be a wall, or you should be a corner. And you can kind of look through this, but that's all that I'm checking here. And I either create you as a wall and position you a certain way, or I create you as a corner and I position you a different way, right? So you see here the same thing happens with corners. It ID is equal to 25. This is on a 5x5 wall. And then I say corner create it, right? And then I say excuse me, then I say its forward is equal to left, just making sure I turn it the right way for that specific room. So all of it is only checking what your ID is and what your name is. And then if I like what those are, or those are specific things I need, I delete that thing and I put in the thing I want. That's it. And then...
So now if I go in and want to change your thing and want to do 6x6 rooms, I need to go in and identify what IDs do what.
Yes, exactly.
Okay.
So if you wanted to make a 6x6 room, or you wanted to make a 7x7 room, or wanted to make a U-shaped room, the reason I've done this is because with that for loop, no matter how many different ways you change it, the IDs of the things you create will always be the same, and you can always go into configuration and make and set it how you want. So you'll need to figure out when it's created, which should be relatively easy. You just have, I'll show you that later, but pretty much if you know the name, if you set the name to something and you set the ID to something, you're good. You should be able to replace walls as you want them and do whatever you want.
So I guess probably a good recommendation is if you're trying to make your own room configurations, like draw it on a piece of graph paper or something, and label each room number as it would be labeled here, so then you can understand how things might need to be rotated.
Yes.
Is that the best way to go about this?
I think so. Yeah.
Okay.
And I'm sure when you were debugging it, you probably had each tile display its ID and name above it, so you could just walk around and be like, look at all the
I remember
Brian's got it.
I remember him doing that.
Thomas,
actually.
Because I had to do the same thing for my cube game.
Yeah.
And I was like, which position are you in my block of cubes or whatever.
Okay.
Yeah.
So hopefully we kind of understand the configuration page. This is by far the longest page because it has so many different configurations and every different tile needs to be taken into account. But you can easily add your own. I believe me when I tell you it's actually not that hard. All you need to figure out is the name and the ID. And then once you plug in the name and the ID, you just tell it what you want it to be.
So at this point, right, this is only looking at a room, so this is not making doorways or hallways yet.
No. Yeah, so we're about to go into the unknown.
Okay.
So now we have a room that has walls. We've made it. We got there, guys. We now, at this point, if you just get to configuration, you've made a room with walls.
You've made one room.
You've made one.
I'm just kidding. That's an important step though, because you go back through that with every room.
That's true. You've made one room.
But like every room copies that exact formula.
So next, what we're going to do is I want to make sure I have this exactly right. We set hallway creation equal to true, and we set room creation equal to false. At the end of configuration, once we've made this room and we know its ID and its names and we've replaced all the walls and stuff, we say, okay, we're no longer creating a room. It's time to create a hallway.
I was looking at chat. It's just a simple 153 line page.
It's a lot of the same information a couple of times.
Yeah, it is. And it's especially if you're working with a lot more room configurations, you're gonna have even a longer page.
Yeah, you could also add another page.
Right.
Okay. So, hallway creation equals true. Let's go back to our main page and see what happens when hallway creation is equal to true. Which is up here. So when hallway creation is equal to true, we call a page called roll weights. So let me explain what we're doing when we roll weights. Every single object that we've created that is wall, we have added to a wall object set. So there is an object set that exists, or there's a list of every single wall that we've made. So let's go to roll weights. For roll weights, we say weight equals 0. What do you say?
I said 6 lines.
It gets a lot easier.
Yeah.
It gets a lot easier. I promise.
It gets better.
I was getting nervous there for a second.
So when page is entered, our weight is equal to 0 for each wall. So for every wall we have, we say it weight is equal to a random number between 1 and 10. If it weight is greater than our weight equals its weight, meaning if we check something and our weight is 4 and its weight is 6, I'll be like, oh, well, okay, my weight's 6 now. And I go to the next one and its weight is 5 and my weight's still 6, I'll be like, I don't want you, right? So only if its weight, the object you're checking, so one of the walls, if one of the walls' weight is greater than the weight we have, then our weight is going to equal that weight.
Okay, so why do you want to do that?
that helps us make not only, so that sets the weight, right? But our target is equal to it only when this happens, only when we have a greater weight. So meaning only the object with the greatest weight will be equal to what I'm about to spawn in, if that makes any sense. So for I've checked all the weights, right? So for each wall, I'm checking every single weight, but I've only gotten to this line if its weight is greater than the weight of all the previous walls. So if there's a weight that's 16 and everything else is 15, I will only grab that object, because this will only have happened once.
And this is only in this one room, right?
Well, actually, this happens for every single wall.
Right. But, okay.
So this happens for every single wall. This can happen, this happens all the time, every single wall.
Okay.
So hopefully that makes sense. 4 is definitely the problem line here, but hopefully that you kind of get it. Its weight is greater than my weight, then I'm like, oh, I like you. Pretty much, forget the do side. This just means I like you, right? It's like, okay, you're the shiniest. You have the biggest number. You win.
And it's like totally arbitrary, right? That's like the whole point. You're just setting it, and then and this is basically you're trying to say like this wall.
Yeah.
I like you because you have a higher weight.
Right, which I set to 0, and I randomly roll these weights, right?
So wouldn't all their weights end up being equal to the same exact?
I never set the weight though. I set the weight once, right? I set the weight when I go into here.
Right.
But then I never assign it again. I'm just reading it and changing my own weight on the object.
So, but wouldn't that mean every single object at the very end has the exact same weight?
No, because I set the weight to 0 here, and then I reset all their weights every time I go into this page.
Okay.
It's line 4 that you're looking at, right?
Yeah,
Because
exactly.
you see it when my weight's greater than another weight, then my current weight equals its weight. But wouldn't they just keep doing that to you until they all equal the same?
No, because I never set weights. My weight is equal to it weight. It weight is never equal to my weight. So I'm never setting their weight.
Oh, okay. Sorry.
Else.
The it was throwing me for.
Yeah,
okay.
yeah.
Okay.
Oh, okay. I got it too.
Okay. I'm sorry, guys. I know this is kind of getting there. Okay, so
Well, if they're gonna hang on, we gotta hang on too. Really.
Yeah. All right. So
Yeah.
so like what this ends up with though is then the weight of this logic cube, its weight is equal to the highest weight of a wall. So every wall gets its weight number, and then you're making the logic cube equal to the weight of whichever wall piece has the highest weight.
right.
Cool.
And that's all just to see which one I want randomly.
Okay.
So line 4 is just to grab something randomly, and this is all it. Just grab something randomly, and my target is now equal to it, which
Sweet.
is the thing with the highest weight.
Got it.
So I grab a wall piece. There you go. 6 lines to grab a wall piece. I go to evaluate position. So, evaluate position, my position, which is the logic cube, this little dungeon logic cube, is equal to target position, which we just set here, right? Target equals it, which is the thing with the greatest weight. So the thing with the greatest weight, I'm now there. Boom. Snapped it. Somewhere the logic cube was out creating room, it snapped to one of the walls. And it says my forward equals target forward. Now you remember, on configuration, we rotated all these walls. So if my forward is equal to target backward, my forward is equal to target backward, I'm now looking at the wall, I'm at the wall pointing outward, right?
Got it.
I'm looking away from the room. And now my target position is equal to the position I have. And clear equals true. Clear is a boolean that lets me know whether or not I want to spawn a hallway. So I wait for 3 frames, and if clear is still equal to true, I'm going to do some stuff. So why do I wait for 3 frames? Each one of these logic cubes, let me go to this big guy. You see here we have like 4 little buddies, right? They're all attached to this logic cube. We'll go here. We'll go to edit. Go to brain, properties, brain, sensor. And I'll turn on the detect sensor. So these guys make a cone, actually. So this detect sensor is relatively big. They all kind of slowly make like a snowman of detect sensors, right? They get smaller as they go up here, and they make a cone of detection. And these guys have, for each detect, so if I detect anything, the logic cube, which is my dungeon creator, clear is equal to false. So I make the clear equal to false. So meaning like this ain't good. We're not spawning here. I have detected something on one of these 4 logic cubes that is attached to you, and let me tell you right now, this ain't gonna work, right? So we say, oh, okay. Well,
and just to reiterate, it's like any object in the world.
Any object.
If it detects that object, then says, "Whoop, no good. We can't build here."
So technically, a few things you could do here, right? I've kind of left this open and kind of modular. I know connecting 4 logic cubes is kind of weird, but so you can do for each detect, and you can say like a name. So if you have something that you don't care, it gets detected, and you give it a name, or you give it some kind of something here. If you say its visibility is equal to false, whatever you want to do, right? If you wanted your dungeon to create over props on each of these logic cubes, changing the detect for each of is where you would do it.
Got it.
Okay.
And that's to make it so that your random dungeon generator doesn't spawn with a tree in the middle of one of the...
Or spawn with itself, right?
That's the bigger problem. Yeah, that would be a problem.
Yeah, without that page, you could have, and I did have for a while, the dungeon just generating stuff over stuff, and that was not a great experience. Okay. And so, if clear is true, we're going to... One second. We wait 3 frames. If clear is true, we're going to call page create hallway if we have hallway creation is equal to true, and we're going to call create passage if passage is create equal to true. We're going through this as if passage was equal, or if we're about to create a hallway. So hallway creation is equal to true at the moment. Else, we don't do that, and we say re-roll. So we go through the whole thing over again, and we pick another random wall, and we do it again. So let's go through that.
Yeah, can you reiterate what the re-roll boolean is?
Yeah, let's do that. So let's go back to roll weight. Roll weights, I grab the highest weight. I go to evaluate position, which positions me at the object. I go and detect out and be like, okay, what's out there? So let's say I detect something. I say, there is in fact something out there. I do not want to use this position. I go back to the main page and I re-roll my weights. So we have 2 different roll weights. Passage re-roll is for exits. We'll ignore that. We'll just do this guy. So re-roll is equal to true. We say hallway creation. We're going to make that equal to false for a moment. We're going to say wall is removing the target that we just had. We're like, we're never using you again. You've disappointed me. Shame on you. Shame on your family. It'll never create a hallway. And then for each of wall, it weight is equal to 0. So all of their weights have been reset now.
Got it.
Okay.
And we wait 3 frames for this to kind of happen. And then we do hallway creation is equal to true again. And reroll is equal to false.
Okay.
So we just step through the same thing. So pretty much the only functional thing this has done is it's removed the wall, set all the weights to 0, and then ran through the whole process over again.
Cool.
Okay. So we're nearly there. So we're now going to create a hallway. So we've now evaluated our position. We've decided we want to spawn something there. We've decided there's nothing out there. It's time to create a hallway, which I believe is actually still left here. Okay. So the first thing we do is we found our target. Our target's been nice. We were sitting there looking out. We go, okay, it's time for you to go. No, we don't need you anymore. So we destroy the wall that was there. We just take it out. And then we create another tile where that wall was. So it was briefly a wall, right? It went from tile to wall to tile again. And then we do a lot of the same stuff here. We increment dungeon items, which is just something we'll go over. We set the tile forward to our forward, so it's pointing the right way. We set the name equal to 0, which is my naming convention for if we know if it's a hallway. So if its name is 0, we know it's a hallway. If its name is 3, we know it's a 3x3 room. If its name is 4, we know if it's a 4x4 room.
Okay.
And then we set the ID equal to ID, and we're incrementing ID at some point here for each of I. And ID is equal to 0. So the first thing you'll notice is I think we have one tile that is going to be equal to 0. Its ID is equal to 0. That's fine because it's one of these weird special pieces. Okay.
So line 9, right? That's when you're deciding how long the hallway is going to be.
Right. So this decides how many pieces of hallway we're about to put down.
So you can't have a hallway shorter than 3 tiles, and you can't have one that's longer than 7.
Right. You can change the number if you want. If you want longer hallways, go for it. If you go beyond 9, you will have to probably add another logic cube to that detect sensor array.
Okay.
So you know how I have 4 connected to my 1 logic cube? You'll probably have to add another one with another detect sensor.
Okay. So you can make super long hallways.
Yeah. Okay. So we've set I equal to 3 to 7. For each of I, so we're back to our old friend, a for loop. ID is going to increment by 1, meaning the first thing that's created, right, was that little thing we replaced the wall with, and I think it doesn't even have an ID technically. It might be blank or it might be 0. But the first one we create is going to be where we want our door. So position equals position forward, and here we have again multiplied by 4. Again, we're using 4 because that's the size of these tiles. So all this means is our position is going to be forward 4 meters. Right.
And so again, if you have tiles that are larger than 4 meters, that's where you change that number.
Right, exactly. So target position is going to equal our position. Tile. So now we're going to be spawning our dungeon hall. And I believe our dungeon hall is just the normal default hallway, right?
Right. That was
at position.
8-1.
Yeah, on target position. Dungeon items. We'll get to that later. Tile forward equal to forward, meaning we're turning it the right way. So if tile's name is equal to 0, tile ID is equal to ID. Cool. Well, 1 second. If the tile's ID is equal to 1, it's time to destroy that. And now our tile is going to equal dungeon door. Meaning our second tile we create, because the first one's 0, the second tile we create is now a dungeon door. And we're going to set its forward equal to backward, meaning it's going to point into the room. Because we're going to be moving out of, right, if the room is here, the hallway is moving outward, right? So our logic cube is pointed this way. So we set its forward equal to backward, so it's pointing towards the room we're leaving.
That's basically just get the arch lined up correctly.
Right.
So it's with the wall of the room as opposed.
Exactly.
So going back up, you just you looked for specifically something with the ID of 1.
Yep.
And then you destroyed that and replaced it with the archway, basically.
Exactly.
Okay, cool.
And then now here it gets a little interesting. So get ready for some interesting stuff. If the tile ID is equal to I minus 1, so before we get to the very end, that's another doorway.
Okay.
And then the last tile.
And so that does all the same stuff making the other doorway was doing.
Yeah, cool. The last tile, we do some. One second.
Whoa.
I minus 1. ID is equal to I minus 1.
So that's the tile before the last one.
Right. We create a dungeon door, and then tile ID I minus 1. We create another dungeon door, but this one I believe gets destroyed as we destroy the other one and is replaced with a tile. So this one's a little bit confusing. So pretty much what you need to know here is the last one we create, and it kind of nullifies via configuration. The tile is created dungeon door at position, target position. Target position is the tile position that we've created. And through configuration, we're like, oh, there's something near us. We're gonna spawn a tile here instead of a doorway and instead of a wall. We're getting rid of both of those, and they're now going to be an empty tile. So this actually goes into the room. Goes into the room. Says, oh, 2 things exist where they shouldn't exist, and they're overlapping. We're replacing it with a tile.
Got it.
And then we say room creation. Yeah, there we go. And then we set room creation equal to true, and that just loops. So there you go.
Okay, so you created one room and one hallway.
One room and one hallway.
The next room.
And started the next room.
Oh yeah, that's true.
we do it all over again.
Yep.
And really, that actually fills it out. Like that's how you do
So
it.
that happens like 8 times, basically in a row, until it creates all 8 rooms.
Right. And it could happen up to 24 times if you'd
Cool.
like it to.
So line 44 is basically saying, does all that, and now we create the next room.
Yeah. And for some reason, through trial and error, I think I needed 2 page enters to make this work. I can't tell you why. I won't tell you why, but it's how it should be.
That's the black magic part. We had to include some black magic in there, or else Zach wouldn't have been happy.
Yeah. Let's see. Beardless Zach, really? That's my name. That's right. Okay, so let's go back to May.
Some of the newer community members are asking, they're like, who is this?
Okay, so here we go. Every time we've created a room, we've incremented rooms by 1. So we've just stepped through what I went through 8 times, right? Because at the very end of creating a hallway, we said room creation is equal to true. And we know when room creation is equal to true, we start the whole thing over again. So if you really think about it, there are a lot of loops going on here.
Yeah, there is.
So pretty much we've gone through that giant loop of creating a hallway and then a room. Now it's time to do that again, and we assume that happens 8 more times.
Mm-hmm. So this is back on the main page, at the assumption that all 8 rooms have been created now.
Right.
So now what happens?
So sorry, I'm bumping onto the table here. Started to rooms equal to 8, meaning we have created 8 rooms. We're gonna say stop creating rooms and hallways. This is getting crazy. This is way too many things. We're done now. So we set hallway creation and room creation equal to false. And we set passage creation equal to true. Cool. So we can see here when passage creation is equal to true, we go back to roll weights. So we're reusing this roll weights code.
Oh no! Never mind.
So
yeah, but getting to the quick questions in chat. Yes, it's totally fine to include Team Dakota employees in your own Project Spark creation.
Yeah.
It's funny.
We're not signed in.
I'll sign in for us.
Okay, cool.
So
Sorry,
we go
go
back
ahead,
to roll weights, and we do our magical thing of deciding which object we want in walls. So we're still using the wall thing, right? Remember, there's this giant pile of awesome walls, and then slowly we take walls out if we detect something. So only the awesome walls that we know we can spawn stuff at stay in this, right? So we check the nice, awesome pile of functioning walls that can maybe one day, hopefully, become doors and or entrances, and if they're super lucky, exits. So we check that, and we evaluate the position, and we say, okay, you pass the test. You get to be not just a lowly wall. Your reward for that is being destroyed. So we immediately destroy them.
You're so mean to the hall.
I know. You started. You're trending on Twitter right now for hashtag all hallways matter.
Okay, so tile equals create dungeon floor. So we destroy the hallway, we create a tile, and we do it at position, target position. So pretty much where we're at the moment. So we say, okay, this was a pretty good place to spawn something. Destroy it, replace it with a tile. And then we move forward, and we create, let's see. Okay, so first we create the hallway, right? Then we say tile ID equals ID, whatever. This is just creating this one tile. And then we say, well, is passages equal to 1? This is actually reversed. 1 second. Is passages equal to 0? So meaning there's not been a passage created yet. Never happened, right? This is the first time we'll be creating a passage. Well, if passage is created, passage is equal to 0, we're going to increment passages by 1. We're going to increment ID by 1. And we're going to say position equals forward. So we're going forward 4, and we're creating a dungeon exit. So we say, okay, here's a tile where that wall was, and here's a dungeon exit. And then we do the same thing next iteration through, because now we know passages is equal to 1. We say, okay, well, if it's equal to 1, we're creating a dungeon entrance. So this is the entrance where the player will start. This is an exit where the player will end up.
And can you quickly go over again what loop of walls you're going through
absolutely.
to figure out
so
what can be used as a passageway and
this is in configuration. So in configuration, we're going through every tile, which is almost everything we create ends up in the tile set. And when we create one of these walls, we say the forward equals forward, and we add it to wall.
Right.
So we set the direction it's turned, and we add it to the wall object set. So the wall object set is only made up of dungeon walls that have been turned a certain way. Okay, so if we go back to create passage, so we find a wall, we destroy it, we create a tile, we set the tile's ID, etc. We say, okay, tile, this is what you're going to be like. Okay, moving on. And we move forward by 4. And if passage is equal to 1, we create a dungeon entrance. If passage is equal to true, we create a dungeon exit. Or, I'm sorry, if passage is equal to 0, we create a dungeon exit. If passages are equal to 1, we create a dungeon entrance. So every time we go through, we're making sure passages increase. And then at the end, we go back to main. And main says, okay, you're done creating passages, you're at 2. Pretty much. You're like, okay, this is equal or greater to 2. Time to stop making passages. That's crazy. And we switch page, so we're completely off. If you've noticed before, we've been calling these pages every single time, right? So this is the first time we're actually going to switch a page in this brain.
So the entire time you've been on the main page, just pulling in pages when you need them.
Exactly. Just being like, okay, what do I need? What do I need? What do I need? And now the page is like, we got passages. Guys, we did it. We did all the work we needed to do. We can get out of here. And it says it's quitting time to every single other page. And we switch page to populate.
But wait, there's more.
Yeah, right. This is probably the page I would assume you'd spend the most time on if you just wanted to mess around.
Yeah.
So, populate is the fun stuff. For each spawn tiles, it weight is equal from 1 to 100. So these are every tile we know that is not a wall and not a hallway. It's just a blank tile. If it weight is less than 25 and greater than 65, so pretty much you can think of this as a percentage.
Right.
There's a 20% chance to spawn a goblin.
Yep, between 85 and 65, cool. Then.
And if it's between 86 and 95, you have, what's that, a 10% chance to create a coin, and you have a 5% chance to create a sword. So this could get so it is very, very super simple to change what we're spawning here.
Okay.
All I go in here, I go to gallery picker, I say I want to spawn a how safe is this?
What
Dungeon gate?
We're good.
Okay. You say I want to build spawn a dungeon gate, right?
Yes.
So we get to spawn a ton of dungeon gates. I position it above plus up. That's pretty cool. So it's just like boop, it spawns right above the tile. Let's say I don't want a sword. Instead, I want let's see.
You can get rid of, we have dungeon up there. You can get rid of that.
Let me do that. Let's say I want. Yeah. There we go. That's
Astro
better.
Blaster.
Whoa, you just took this dungeon into year 25,000. I don't know.
What?
Nailed it.
I was trying to think of a future world. I couldn't think of anything.
And,
well, I think I was going to say 2000s originally, and I was like, wait, we don't have Astro Blasters yet, so
you could
that
say
doesn't
the
work.
enemy is Void Fiend. So now we have Void Fiends, we have Astro Blasters, and we got coins. We can
Right,
say,
and you can put in more
Kodak
enemies,
crystal.
so you can
Right.
say like when a weight is greater than 5, less than 10, then like
Right.
a super awesome enemy that has a 5% chance of coming up.
Absolutely.
Or if you want to do like a gang of enemies, you could save those out as an assembly and then choose them to create a
And-
spawn tile.
Get ready, guys. Your mind's about to be blown.
Well, I'm going to brace myself.
You could also do this, which is it. I'm sorry, I gotta use the keyboard and mouse now. Okay, it, weight, or it name, not that name. Name, the name I chose, is equal to 5.
You're in the 5x5 room.
Yeah, and ID is equal. You could set a boss in the center of the 5x5 room. If you'd like to make a boss and you have a specific type of room, you could say, well, if my name's 5 and my ID is, I think, off the top of my head, 16,
Math?
maybe.
Yeah, close enough. It's
Whatever.
somewhere in there.
13.
And my ID is something. 13, yeah. You could say, make a boss. So every 5x5 room would have a boss. Or you could do this weight thing, and you'd be like, well, maybe only half of them. So, like, and your weight's over 50, then every other, something like that. So that's the cool part you can do at this page. So if you want to change what we're spawning in here, obviously we could change. I have Void Fiend here. You could go into the world picker, decide whatever you want.
Right, your own custom enemies.
Whatever, your own custom enemies, your own custom stuff. So if you want to change what spawns in the dungeon, you go to populate. And then weights, so pretty much lines 2 through 5 is how you change. And you can obviously feel free to add more.
All right, so this is awesome. I didn't even think about that. Like,
Yeah,
that's
populate's
awesome.
really neat.
It's pretty. Unfortunately, there are some parts that are a little bit complex, but it's all modular, all relatively modular, all relatively able to mix and match. And then we just display the dungeon floor here.
That's what took you the longest, right? That
That was hard. Oh, I can't even remember how long I spent on that. And then exit has power. So the last thing is we switch back to page 1 when the exit has power.
Let's do it all over again, guys.
Yeah, and exit has power here. So when you interact, you turn the power on of our owner, and our owner is the exit.
Got it. It's the whole thing. Mm-hmm.
Yep. So pretty much when you interact with that door, things are going to go crazy. So let's go all the way back. Not to the character. Let's go all the way back. Into init. So here are the interesting things. We'll kind of wrap up here, maybe take questions or whatever. But I'll just briefly go over the init page one more time. So dungeon item. Every single thing we've made has been part of dungeon item. We destroy all of it unless the player has it equipped. Meaning as long as you have something that you've equipped on the player, that will stick around. Like a sword or a blaster or something like that. If it is not equipped to the player, it is categorically being destroyed. And we're setting all of our tiles equal to nothing again. And we're setting all of our numbers equal to nothing. We're setting all of our vectors equal to nothing. And we're setting our So here's another cool thing, guys.
Oh. No, I think I know what you're going to do.
So you see how floor is equal to 1, or you're incrementing every time. You could say on this page, this dungeon stuff, right, is equal, only when is equal to 1, dungeon hall equals this. When floor is equal to 2, you could have another dungeon hall equal to, I don't know, this but blue.
Yeah.
So you can change, or you can randomly roll these things if you'd like to as well. So you can, if you had a couple of different types, you can set this a couple of different ways. So you can change the look of it based on what floor you're on. It'd be like on even floors, do this. On odd floors, do this. If the floor is like 5, then this is what it looks like.
So as you get deeper and deeper into the dungeon, you can make more and more epic pieces.
And you could also populate the dungeon based off the floor too.
Exactly.
Yeah. So maybe in my last dungeon, I will definitely want my 5-5 to have a boss or whatever.
Right. Exactly. And then we just start it all over again. There you go. So that's that. And if we go back in here, we'll build our dungeon.
That poor Logic is
still
such a workhorse.
Void Fiends? I forget. Did you actually change that?
Yeah. So we should see Void Fiends and Astro Blasters.
Yay!
Oh my god! Oh, they're after me! Also, so if you notice, I didn't really do anything with the character's brain. By default, you can kind of jump up here. But feel free to change your character brain if you'd like.
Yeah. I think you can, if you like jump up onto one of those stones, you can get over. It's kind of hard, but yeah, you probably do want to change up your character a bit to make it kind of impossible for them to jump over stuff. Probably don't want to give them double jump.
Yeah, or make it a very small double jump.
Yeah.
I want to find one of these Astro Blasters. I guess we're going to the next floor.
A question: Did you spell origin wrong on purpose?
Yep. Next question.
Who's a wizard?
Let's see. There we go. Astro Blaster.
All right.
Oh, it doesn't have. Oh, there we go. I have a default shoot. Yeah. Oh, next to another one. It's like barely any % chance. Yeah. Okay, there you go. So there you go, guys. That is the how to create a dungeon, or how the dungeon creator works. So hopefully you enjoyed that. Hopefully you will get some use out of this assembly. Obviously,
this is awesome.
Any questions you have, we'll try to answer. If you find yourself a bit confused, do some research on for loops because they are used heavily.
Yeah. So I'd say this gets you 50%. What we give you gets you about 50, maybe even 75% there of making a Diablo-like game. Then it's just like adding more customization on top of that.
Pretty much. I mean, you still have to do the character, which may or may not be coming in another pack if I could somehow convince people to let me make a Diablo character. But you still need to make the character, but obviously you can have as many kinds of different enemies as you want. You can change the type. You can easily, very, very, very easily, just let me go in here and kind of give you an idea. Do I want to glue all this? Sure. Well, we'll just do this. So I could just change this guy, go to properties, go to his appearance. We're going to make this a red gate, right? So, I mean, since it's changed every single time.
That's like Doom style.
Yeah.
That's not.
But you can see, like, I've
Get the red key to the red gate. Blue key to the blue gate.
But, like, I can change the color in here, and as soon as I start again, I'll find this guy, and he will be that color. So you can go in there, change those templates.
Oh,
there
that was really convenient.
Yeah.
I like that. Out of the chances, entrance and exit are next to each
I know,
other.
right?
There's like a 1% chance or so. But
it's pretty slim.
So yay!
There you go. So you can obviously change those guys super easily, super modular, and there you go. I think.
And you could probably, you could set your entrance to only be in a room of a certain ID, meaning like your entrance is only a really tiny room and your exit's only in a really big room.
Yeah.
So that's how you could do that.
To prevent,
yeah, I kind of didn't want to add that because I felt this was already complex enough. I didn't want to have to. But if I was going to do this, what I did have working and we kind of just decided to move out is just when you're doing it, detect like how far away.
Okay.
And
how hard do you think it would be to change this random dungeon generator to be based on sample noise instead of random generation?
Sample noise instead of random generation. Depends on what we're trying to sample.
Yeah. Why don't we have our trusty, very smart community member Mescat answer that for us with a tutorial after this comes out.
I mean, if you sample the noise and you can put it into an integer, it'd be super easy.
Sure.
But we are going to have to right now digest any information you sample as an integer. Obviously, how it rolls all that stuff is up to however you want to do it, but you're going to have to somehow put it into some integer stuffs.
Create your game as you play? Any Spark can do it. Spark, activate the portals.